One of the important functions of the MAC sublayer is the coordination function. That is the mechanism used to avoid collisions. Remember that a collision happens when two or more stations are transmitting and there is an overlapping of two or more digital signals in the same channel. The DCF, the distributed coordination function, is the basis of the standard called CSMA-CA access mechanism used in wireless. DCF makes it possible for multiple stations to communicate without the need of a central control. Like Ethernet, DCF CMA-CA first checks to see that the radio link is clear before transmitting. To avoid collisions, stations use a random backoff time after each frame, with the first transmitter seeding the channel. It's very similar to Ethernet. The difference we will see is that in Ethernet we could sense, we could detect the collisions, but it's not the case in wireless. Then we use another mechanism to detect the collisions. Also, most of the wireless LAN uses DSF CSMA-CA MAC access type. This is because this access type is the same as standard Ethernet, which provides contention-based service. This DCF can be used in independent BSS, that is ad hoc networks, as well as in infrastructure BSS, that is wireless networks with access points. Well, then we need to talk about the CSMA-CA algorithm that comes from carrier sense multiple access with collision avoidance. The slight difference compared with Ethernet technologies is that in this case we don't use collision detection but collision avoidance. If two stations check the channel at the same time, for instance, the check is performed listening if is some signal that is transmitted over the channel. Typically the carrier signal. And then if two stations check the channel at the same time, both get as a result that the channel is free and send, a collision occurs. That is, if two stations then transmit at the same time, a collision occurs. Collision detection is not possible during radio transmission because the performance of the received signal is negligible compared to the transmitted signal. Remember, we already talk about the attenuation, that is the free space. The free space. Do you remember path attenuation or loss? Is very important. Then typically we could lose several dBs from the transmission until to the receiver point, that is the station that is in the same wireless area. The CSMA-CA method tries to avoid collisions by not accessing an occupied channel immediately as soon as it becomes free. This is the basic principle that use CSMA-CA to avoid collisions. Each station waits for a random time before rechecking, which means that the probability of collision is reduced. The attenuation of the radio signals in the medium cause two other media access problems called the hidden station and the exposed station problems. We will see this detail, the hidden station and the hidden and the exposed station. Then, in fact, the CSMA-CA is a method where when a frame is ready to be transmitted, the transmitting station checks whether the channel is idle or busy. If the channel is busy, the station waits until the channel becomes idle. If the channel is idle, the station waits for a particular amount of time that is called IFS, interframe spacing, and then sends the frame. We will see that there are different IFS, but in fact, at any moment, once the channel is checked and the channel is idle, the station always waits an IFS, an interframe spacing time. After setting the frame, it sets a timer, then waits for acknowledgement from the receiver. That is, this is typically different from Ethernet. In Ethernet, there is no acknowledgement. In this case, the acknowledgement is used in order to detect if the frame could be received by the destination station. If the station that transmits the frame receives the acknowledgement before the data timer expires, it marks successful transmission, and that's all. Otherwise, if the station doesn't receive the acknowledgement, it waits for a time period, employing simple exponential backoff algorithm to avoid collisions and restore the algorithm in order to retransmit later the frame. Remember that the exponential backoff algorithm is very similar to that used in Ethernet, in CSMA-CD. Then there are typically, because of the propagation speed or the propagation delay in the free space, the frame that is transmitted, for instance, in this case, the three stations A, B, and C are in the same Wi-Fi zone, Wi-Fi area, and A need to transmit a frame, a data frame, then check the channel. The channel is free. Once the channel is free, the station A wait an interframe spacing time that in this case is called the DCF, the distributed counterfunction. That is the higher IFS than, for instance, the SIFS, that is the short interframe spacing. Then the station A waits for this time and transmits the frame. The frame arrives later to the other stations. If the frame arrives later to the other stations, the problem is that a collision could occur. If the collision occurs, for instance, the B station will not receive intelligibly the data frame, then the process of the exponential back of time will be calculated, and the station A will need to retransmit later the data frame. If, for instance, a collision doesn't happen, then the data frame arrives clearly to the B station. Then the B station, after a while, typically SIFS, that is a short interframe spacing time, will send an acknowledgement frame to A. And when A receives that acknowledgement, A realized that the data frame was clearly received at the destination station, and then remember, in that case, marks a successful transmission. Well, remember then that if for instance, another station or the same station, for instance, fail in order to transmit, for instance, in this case, the data frame, then back of time will be added to the DCF interframe spacing the next time. Here we are some assumptions typically. Stations A, B, and C and D can reach each other. Then in this case, typically, this is another example, another scenario. Then, for instance, in this case, the station A need to send a data frame to another station called D. Then, typically, the A station transmit the data frame, and the D station, this separation, remember, is the SIFS time. And in this case, for instance, during this transmission, perhaps the station C need to send a frame, and the station B need to send a frame. But in fact, they have typically, if the network is too busy, they have typically a back of time calculated. Then the back of time typically is randomly calculated. Then typically the back of time is different in the case of B and compared with in the case of C. Then typically what happens is that when the channel is free, this situation is detected by B and C, but both wait not only the DIFS time, but the backoff time. With considering that the backoff time are different typically because they are randomly calculated, then for instance, one of those stations will start transmitting earlier than the other. Then once the station C, for instance, transmit the data frame, then B need to wait for the idle in order to transmit. Once the station C finish to transmit the data and the station D, for instance, confirm the correct reception of the frame, then typically B could waiting the back of time, the rest of the back of time, then could be transmit his data frame to the station D. Then this is a typical scenario where three different stations need to transmit a frame to another station, and there is a process of contention because there is only one a common channel, a shared channel to transmit the frames. And this is an additional mechanism that could be used to sense if the channel is busy or idle. This is very useful in order to save power. The NAV, the network allocation vector, is in fact a virtual carrier sensing mechanism used in the Wi-Fi and WiMAX networks. And in fact, this mechanism uses the duration field of the of the frame. Remember that in the frame structure, we already see this field duration. The duration, in fact, is the time required to transmit not only the data frame, but the time estimated to transmit the data frame and receive the acknowledgement frame. And this is then the mechanism. This is the information that is specified, that is indicated in each frame that is used in order to save power, because in fact there are typical wireless stations that are often battery powered. So to conserve power, the station may enter a power saving mode. The station decrements its nav counter until it becomes 0, and at which time it is awakened to sense the medium again. That is, the station don't need to sense every time the carrier in the channel, but only sense the carrier in the channel, and if a frame is be transmitted, all the stations could read the duration field of that frame, and then enter in that awakened that is in that excuse me, I missed the word, in that sleeping mode, in order to save power. And after that duration time, the station is awakened to send the medium again.